Hi, I'm an old guy and I do maths, and the question today is, what are the probabilities? So you've seen the header illustration, and I'm going to attempt very poorly to reproduce it here. So we have a dartboard which is composed of three circles, a small one, a medium-sized one, and a larger one. And the radii of each of these is obviously different. So again, if I try to reproduce it here badly, the radius of that is 2, the radius of that is 10, and the radius of the large circle is 20. And the question is, if you throw a dart at this surface and you have the assumed certainty that you will hit the board, but in a random pattern, so there's no skill involved, what are the probabilities that you might hit this piece of the board, or this piece of the board, or this piece of the board? Well, let's consider the large part of the board. If this were all you had, and you were absolutely certain that you would hit it, then the probability of hitting it would be 1. But that's not the case. Let's deal with the first ring, the outer ring. Now, the probability of hitting this part of the board can be calculated by finding the area of the large circle and subtracting the area of the smaller circle from it. So what is the area of the large circle? Well, pi r squared is our friend, and so we take the radius squared, which is 400. That's 20 times 20, and multiply it by pi. So what do we get? 400 times pi. And that gives us 1256, we assume these are centimeters squared. Okay, I'm rounding ish. That should probably be 1257, but we're just doing this approximately and quickly. The smaller circle has a radius of 10, so that is going to be 100, 10 times 10 times pi, which is pretty easy. There we are. Again, we'll say 314 centimeters squared. Now, so the probability of hitting this, the area between the outside of the dartboard and this first circle, is the difference between these two out of the total area of the board. So what is the difference between these two? That is 942 centimeters squared. Now that is this area here. That is 942 centimeters squared. And so the probability of hitting this is 942 out of 1256, which we are going to reduce to a percentage. And that's done easily by dividing 942 into 1256, which gives us 0.75. Just see that. And that is 75%. We have a 75% of a chance of hitting that area. Now, what is our chance of hitting this inner ring? Well, it is the area of this inner ring divided by the total area. So what is the area of the inner ring? I'll just do that over here. Quick and very rough illustration. So this is the smaller ring, r equals 2 and r equals 10. So it is 314, which we already know, 314 centimeters squared minus 4 times pi, which is the radius squared, 2 squared times pi, so 4 pi, that equals 12.56. We will we'll use the decimal. 314 minus 12.56, which gives us 301.44. We'll call it 301. We're doing this very approximately and quickly. So this area in here is 301 centimeters squared. Now, what is the probability of hitting that? Well, it is 301 out of 1256 out of the total surface area of the object. So what is that as a percentage? 301 divided by 1256. It's about 24%. There we are. You can see that 0.239. We'll call it 24%. Okay, so we are down to 75 and 24, which is 99%. We've covered 99% of this, the area of this. And what do we have left? Well, we have the area of the small circle, which I will finally colour in here. And we already know that that is 12.56. You'll see my reason for leaving the decimals in a moment. And that is out of the total surface area, 1256, which equals 1%. So the answer is that you have a 1% chance of hitting this, you have a 24% chance of hitting this, and you have a 75% chance of hitting this. And that is how we calculate the odds. Sorry, I'll just put this into shot and you can see this again. So this area here is 301 out of 1256. We calculated the 301 here, giving us 24%. We know the area of the small circle, which is 12.56. As I said, I left the decimal in. So 12.56 out of 1256 gives us 1%. You have a 1% chance of hitting that, a 24% chance of hitting that, and a 75% chance of hitting that. That is how you calculate the odds. Thank you for watching. I hope you found this useful and helpful, and that you can go on and understand these. There will no doubt be other problems involving this sort of thing. We might look at a probability distribution or something like that. Anyway, I'll see you next time. Thanks very much for watching. Bye.